All right, so today I'm going to be starting a new series where I pretty much just code every single day until I actually have my dream software engineer job. Right now, I actually don't want to say what it is because I don't know, it's like this mindset thing. But, anyways, we're going to be following this exact roadmap right here. And once we complete this, I'm going to do the neat code 150. And hopefully by then, that'll be like what, 200 problems solved. I will have my dream job by then, right? It's a lot of problems. And also, whenever I am solving these problems, I'm going to be solving them in an interview style way. So I'm not just going to like be silent the whole time. I'm going to be explaining my thought process. And then I'm thinking about like also documenting my applications for like jobs and whatnot. If I go to my Gmail right now, it's like 30, 40 applications I submitted. But yeah, I don't know if I'm gonna do that. But yeah, for right now, I'm gonna just stick to this, make it simple, and yeah, I'm gonna be leak coding every day. I'm gonna be doing multiple problems. Right now, I'm doing C++, but I'm gonna try to transition into Python because it saves time during interviews and it's just easier to read. But yeah, so right now I'm just gonna do C++ and like start at the top of this list. Oh, sorry. Start at the top of this list and just go down. And once I get all these knocked out, hopefully by like problem 10, I'm pretty proficient in Python and I can actually do leet code style questions in Python. Yeah, it's an easier language than C++ anyways, so. And another thing. Yeah, I think that's, yeah, I was going to say some other stuff, but yeah, I think that's pretty much it. But yeah, I got to answer these in like interview style. I'm like pretty fresh, pretty new to leet code, so I'm going to be struggling. This is probably going to be a little embarrassing, but a little humbling, but you know what I mean. All right, let's start with this. So we're going to be starting with contains duplicate. Given an integer nums, return true if any value appears at least twice in the array, and return false if every element is distinct. So return true if any value appears twice, okay, and return false if every element is distinct, okay. So I'm not even gonna read like anything else. I know you're supposed to write like write pseudocode or something like that, like above. I'm usually like on my Mac whenever I do this stuff, so it's like I don't know like the shortcuts yet, but like I'll get more proficient on Windows as I go. So return true if twice, and then return false if distinct. Okay. So our first example, this is going to be true because there's two ones. And then this is going to be false because they're all distinct. So that's pretty simple. So we're just checking if it has a duplicate. All right. So common practice is to like find like a way to like hard code it before you do any coding. Just find like the most like bare bones hard coded solution, brute force, and then try to evaluate time complexities and seeing what's like a faster time complexity. But hold on, I'm gonna hide my shit real quick. All right, I had to do that because you know, like the little sidebar in ChatGPT, that shit gives away like too much information. I'm not gonna lie to you. But anyways, um, that's what I was gonna bring up. Time complexity. I don't know anything about time complexities, so I have to learn about that too. So this is also gonna be that. So help me learn time complexities in relation to leet code style problem. Just give me the basics for right now. I know I need like, I know O of 1 is like the fastest or some shit. I don't know, bro. I actually don't know. Okay, what is complexity? Time complexity tells you. I need to learn space complexity too. Time complexity tells you how the runtime of an algorithm increases as the input size of n increases. Think of it like this: O of 1 is instant, constant time. O log n fast. O of n linear growth. O n log n sorting level speed. O of n squared nested loops slower. O of 2 to the n or O of n factorial is brutally slow. Okay, so complexity, constant, logarithmic time. Okay, so this is like the hierarchy. So we want to aim for this, and then if not this, if not this. Okay. Example, like accessing an array element. This is instant. Okay. Binary search. It's O log of n. O log n. And then linear is like one loop over the input. Okay, so one pass through a loop. And then O and log n linear. So like merge sort, quick sort. So some patterns we'll see: single for loop, O of n. Nested for loop is O of n squared. 2 pointers is O of n, because it's one pass. Okay, yeah. Divide and conquer is O log of n. Sorting is n log of n. Recursion is okay. And then hash maps or hash sets are O of 1. Okay, you're actually like snitching. What about space complexity? Yeah, I'm gonna need examples, I'm not gonna lie. So pointers, counters use O of 1, recursion, O of depth. So I guess like I is gonna be like the depth. I don't know what the fuck I'm saying. Okay, yeah, that makes sense, I guess. I guess I'll just learn as I go. I guess every day I'm gonna review time complexities, and I'm gonna quiz my time complexity knowledge. So I'm gonna start with the brute force approach here. And I feel like the most brute force way of solving this is sorting it out and then checking if I plus 1 is like the same. So they gives us a vector, so we're just gonna do sort wouldn't it be like nums dot sort nums dot begin, comma, nums dot end, be some shit like this, right? And then after we sort it, we get everything in order. So then we would just check if like nums of I plus 1 equals nums of I. Oh shit. And then we would do like if true, return, or like if that, left that up there, return true, right? Else continue. And then once we exit the loop, we could just say return false, because we know like. Alright, so this would be, since we're iterating through the array, I would say O of n squared, right? Time complexity, and then space complexity. I didn't really read that much too. Alright. Linear space, logarithmic space. Pointers, recursions. Okay, so memory doesn't really have much to do with like I'm using a vector. So how many bits is that? I don't know this shit. All right. All right, what would be don't give answer, but I wrote brute force approach. What would be time and space complexity of my approach. I assume for space for time complexity, it would be O of n squared, I believe. Since we are going through the loop X amount of times, or size amount of times. Oh wait. I didn't even attach this bitch. There we go. I don't know if sorting uses extra space. I should probably open up like, we'll do complexity nodes. Okay, so I don't know if sorting uses extra space. Then you're doing a single for loop for comparing adjacent elements. How many comparisons does the loop make? It makes size amount of comparisons I give answers with explanations. So sort is n log of n. N is the number of elements in nums. Sorting dominates the runtime. Okay, so using sort is O log of n extra space. It does not make a copy of the array. Okay, so sorting n log n, because so for the space complexity in place for fundamental types like int, only using O log of n extra space for the recursion stack. What bro? English? Wait. So it does not make a copy of the array. Okay, so it's not making a copy. So it's, I don't get why it's log n. Put it into two sentences here with terms I don't. That makes sense. Okay, that makes sense. That makes sense. Alright, so any basic complexity is O log n, because you split n amount of times before reaching 1. Example, 0. Example, we'll just do this. We'll do 0, 8, 1, 4, 2, 2, 3, 1. Split 3 times before you get to 1, which is log. Okay. Alright, so now we know that the space complexity for this is is log n, and the time complexity is n log n. So now we have to find a better solution. So we know that hash sets and hash maps operate in O of 1. So probably going to want to do something. Yo. Oh shit. Probably going to want to do something related to that. So I'm thinking we get hash set. We're gonna run the loop one time, but doesn't that make it fucking log n or some shit by running the loop once? Whenever we run a for loop one time, this is n time complexity, right? Okay, so I guess we would have to run the loop one time, which would give us an n time complexity, which is better than this for my solution. So I'm thinking we get the hash set, we run like a range based loop, we check if the value is in the set. If it is, return true. If not, continue and insert current element. Then after the loop, we get to return false. So I think this is how I would implement. I don't really know the syntax behind sets, but I'm gonna just do unordered set, and then I think it's like should be like an integer because we're storing one thing. It's a set though, so wouldn't it be two things? I don't know, bruh. We'll do unordered set. We'll call this shit like check. Then we'll do like for int num in nums. We'll do if check dot count num. So we're pretty much checking if the number exists in the set, which the first pass it's not. We'll do return true, and then if it doesn't, we'll do count dot insert num. I think this is the correct syntax. We'll just insert it think. I actually don't know. Do I need to keep track of I for like indexing? I don't know. And then we'll do like return false. Yeah, I don't know if my syntax is off. Can I run it? Okay, I actually don't know why this. Does it say why it's off? Do we get hints? Overloaded function cannot be resolved. Did you mean to call it? Oh, this is check. My bad. Yo, that's my bad, gang. Oh shit. Okay. So we passed first try. Now, I don't know if this is the fastest we can do it. I'm gonna sit and ponder for a minute, because this would be O of n, right? This would be O of n, right? Okay, so this is O of n time complexity. Space complexity, let's debunk this, like, let's decode this shit. So we learned that sorting puts us in log n. I don't know, space complexity is O of n as well. You're storing up to n elements in the unordered set. So space grows linearly without input. Okay. Yeah, it's growing linear. N amount of times. That makes sense. Okay. Time complexity, O of n. Space complexity, O of n. You've nailed both brute force and hashed approaches. Is this optimal? Okay, it's optimal. Hey. I mean, this is an easy problem. This is problem number 1. So, I mean, I guess I can't really be too happy. But what the heck? Alright. Yeah. So, first leak code problem of the journey. I'm going to come back to this video. I'm going to watch this video. I'm going to be making millions of dollars. This is strictly for documentation purposes, strictly for accountability purposes. This isn't really for like personal brand or like any of that other stuff. I have a completely other channel for personal branding purposes and like motivation, all that other stuff, like actual content. This is strictly for myself. Oh yeah, one more thing that I did want to include in this. I want to answer questions, so be sure to leave like any question down below or any comment, and like in the next one, the first thing I'll do is like answer questions, and then I'll jump straight back into like the coding and like the time complexities, and then yeah, that's pretty much gonna be it for that. 1 out of 50 down. We'll be back tomorrow. Probably gonna study some Python right here, like right after this few hours, and then we'll see if I can solve the next one tomorrow in Python and then solve it in C after. But yeah, that's gonna be the end of the first episode. And I don't even know how to end videos. How do you end a video? Like, alright, I'm just gonna end this shit. I'm not gonna lie.